on next Wednesday, there won't be no, there is no class next week. I had to attend some important meetings. I was thinking about whether having your chance to have another quiz or just no class, but because you had the quiz last week, right? So we are not going to have a class next week. So we have covered pretty much about differentiation, derivatives, right? So for example, we have covered something like this. This is same as logarithmic derivative. So sometimes I'm going to use log or ln, same. So some textbooks use ln for the logarithm with the base e. But I simply just use going to log in many cases. So were you able to find like 10 logarithmic derivatives, and have you practiced that? So I was wondering whether the ChatGPT gave a good example. Right. Before I proceed, maybe we can do some more things, like when yx inverse tangent x, and how do we find derivative? So x is tangent to y, right? This is cosine y, sine y. So we first calculate dy dx. Cosine y, sine y. This is dy t sine y over cosine y plus sine y dy t cosine y. So if you take the derivative of sine y by y, what do you get? Cosine, right? So the first term becomes cosine y divided by cosine y. Second term is a little bit more complicated because it's a composite function derivative. So sine y times, you can regard this cosine y as gy, then it becomes minus cosine square y, right? And then dy t cosine y. So it's 1 plus sine y times minus cosine square y minus sine y, 1 plus cosine square y sine square y turns out to be 1 plus tangent to square y, and this is nothing but 1 plus x square, right? So therefore gy dx is actually 1 over dy dx is 1 over x squared. So we have the following result, that if t inverse tangent x or arc tangent x is 1 over 1 plus x squared. Probably you have covered this derivative in your freshman calculus. Maybe another example. Y is inverse cosine x. So same as before, x is cosine y, right? So dx over dy is minus sine y, but we have cosine square x plus sine square y is equal to 1. So sine square y is 1 minus cosine square y, or sine y is square root of 1 minus cosine square y, right? So this is minus 1 minus cosine square y is minus 1 minus x squared. So dx dy is 1 over dy dx minus 1 over 1 minus x squared. So we can calculate various one minus x squared square root. So since we have covered various kind of derivatives, now we are ready to do some serious study about differential equations. So what is differential equation? So equations containing derivatives. The simple definition. And how do we classify the differential equations? Classification. There are two terminology. One is order and degree. So order is a power. So you say dx, dy, sometimes you say simply y prime, you say first order. Dx squared, d to the n, y double prime, the second order. Etc., etc. You can have dxn, dn, y, y to the n, nth order. So differential equation is characterized by the highest order. I'll just write down DE as acronym. Acronym means shortened word. The differential equation, I just write down DE. So DE is acronym for differential equation. So the DE is characterized by the highest order of derivative. On the other hand, degree means power. So if we have if your equation contains am I going too fast? It's okay. Say dx dy square. You say second degree. First order. Or degree 1. 2. Mth degree nth order. So if term higher degree than 1 we call nonlinear differential equation. But nonlinear differential equation is very difficult to solve. So we are not going to consider this part during this class. So nonlinear differential equation is not the subject of study for this class. But nevertheless, nonlinear equations sometimes come in actual engineering problems. So maybe you have a chance to take more advanced mathematical class, then maybe you'll have a chance to learn about that, but not this semester. There are the classification about derivative. This is called dependent variable. X is called independent variable. So a number of this is also acronym for the number of independent is equal to 1, or just x, we say the derivative is ordinary derivative. The typical ordinary derivative is just simply dx dy. Also the main subject of derivative for this semester. But if number of independent variable larger than 1, then we are talking about partial derivative. So for example, u x, y, z, then we can take the partial derivative such as partial x, partial u is defined as delta goes to 0, delta u x plus delta y z minus u x y z. Same as for partial y. Partial g, partial u, u x y z plus delta minus u x y z. So anybody who is not familiar with the partial derivative, raise your hand. So you are running this for the first time? Okay. There is always a first time. The rest of you probably have learned about this. Freshman calculus, 미적분학, right? So let's spend some time to study this partial derivative because some of you are not quite familiar. But definition is the same as before. So for example, if u x, y, z is just x, y, z product, and let's try to calculate the partial x. You have delta x plus delta y, z minus x, y, z, right? So this is basically delta x, y, z plus delta y, z minus x, y, z. So these two terms cancel each other, and simply y, z. So it's exactly like if you take I may have a pointer somewhere. Oh, here. Did I do something wrong? Okay, thank you. if you have x, y, z, if you take the partial derivative, you just take the derivative about x. So if you just take out x, it's 1, right? Derivative of x by x is 1, right? So you can just regard y, z as constant. To see if this is true, we can also check for next page. So I'm not going too fast, right? It's okay. U, x, y, z was x, y, z. Now partial y, partial u is take the limit delta goes to 0, delta u x y plus delta z minus u x y z, which is basically delta x y plus z, z minus x, y, z, delta x, y, z plus x delta z minus x, y, z. So these two cancels each other. Then we have x, z. So same as you just take out y in this case. If you take derivative by y, just you take out y, then you have xz. So you can still regard x and z as a constant. Same for z, partial z, partial u. Very elementary example, but it's a really good example to understand what is partial derivative. Delta u x y z plus delta u x y z delta x y z plus delta minus x y z, same as x y z x y delta minus x y z over delta. These two cancel each other. X y. In about 5 minutes, I'm going to have a surprise quiz. So if you like to let your friends to come in, you have 5 minutes. After 5 minutes, we are going to lock the door, and we are going to have a 5-minute surprise quiz. I told you in the beginning of the semester that we are going to have 1 or 2 surprise quiz, usually on the lowest attendance day. Yes. Okay. So you have 5 minutes to let your friends come in. Exactly 3:30, you are going to have a surprise quiz, 5 minutes. Very simple quiz. 네, 펜 있어야 돼요. If you don't have a pen, you can use 혈서. Okay, let's do some more complicated example. U x square plus y square plus z square. So if you have educated gas, you can just, for partial x, you can regard that y and z as constant, right? So right. So these two cancel each other. It becomes x squared plus 2 delta x plus delta square minus x squared. Again, this cancels each other. 2x plus delta is 2x. So when you take a partial derivative with respect to x, then you can just disregard this y and z as constant. So same thing. Partial y, partial u. Then I think just 2y, right? Partial z, partial u, 2z. So I'll just give it as a homework so you can check. You have 2 minutes. 종이도 필요할 텐데, piece of paper. 종이 갖다 줄까? 아무 종이나? Now, composite function of if u, some function of composite function. In that case, okay, one student appears. Clock is ticking. So I just write down the answer and then give you proof. So partial x partial u is dg du partial x partial g. Proof. By definition, partial u is, of course, delta goes to 0, right? Okay, why don't you lock the door? The lucky students just come in. Okay, you should lock the door. Okay, I'll just continue. Surprise. Number 1. Okay. Write your name. 5 points. To write my name. Another 5 points. Real quiz. Txt sin x. 5 points. Okay? So you will get 15 points extra. And I will give you 10 minutes. So when U is a composite function of G through G this is probably the most common example of a composite function for partial derivative. So partial x partial u is you take the limit delta u gx plus delta y z minus u g x y z. Then g x plus delta y z can be written as g x y z plus delta g. So it turns out that we have delta u g x y z plus delta g minus u g x y z. In mathematics, I told you that you can do many things by doing nothing, right? So doing nothing means you just multiply by 1. So in this case, I must divide by delta g, multiply by delta g. So you can have delta g, u, g plus delta g minus ug, delta g, delta gx plus delta yz minus gxyz. When delta goes to 0, delta g also goes to 0. So this part becomes simply dg du, and this part is simply same as before, partial g. So when G and U is given by U x through G x y z. Then partial x partial U is same as t g t U partial x partial G. And same goes for partial y and partial z. The one appears even after the surprise quiz is over. And likewise, partial y, partial u, t, g, t, u, partial y, partial g, partial z, partial u, t, g, t, u, partial z, partial g. So this is called named chain rule. Probably you have learned this also in freshman calculus, right? So what do they call chain rule in Korean? 한국말로 뭐라 그래요? Okay, let's just say chain rule. There may be some Korean terminology, but I'm not too familiar with those. So for example, 연쇄 법칙? Okay. Say example. U is square root of x square plus y square plus z square. So let's say G so U is the square root of G, right? So what is dg du? Twice over G over 1, right? So if you have a square root of G, and if you take the derivative by G, dg d square root of G is 1 over 2 square root of G, right? Same as x. So partial x G is 2x, right? So partial x partial u is dg du partial x partial u is 2 square root of G, 2x is square root of x square plus y square plus z square over x. Same thing will go for partial y, partial g. What is 2? It's 2y, right? Partial z, partial g is 2z. So using this as a box, you can have partial y, partial u is y over square root of x square plus y square z square. Partial z, partial u, y square root of x square plus y square plus z square. This time we'll complicate the example. We have a square, 1 over square root of x square plus y square plus z square. The same as before, right? G so what is G? G square root of G. This is minus, right, times T, G, T square root of G. Minus G square root of G over 1. Or minus we have 2. 2 G to the 3 over 2 over 1. As before, the partial x partial u is minus twice of x squared plus y squared plus z squared over 3 over x. Partial y partial u is minus x y 2 x squared plus y squared plus z squared z. We have 2z. 2 so these two are cancelled to each other. Minus x over x squared plus y squared z squared 3 over 2 y x squared plus y squared plus z squared z. How many of you are taking electromagnetic field? 전자장치 있는 사람? 없나? What? So this is basically electric field with 4 pi something. That's actually what Newton did in 1650. The gravitational force between, for example, this is Earth, this is Moon. The gravitational potential V, if you regard the Earth as a center, this point is x, y, z. G, M, square root of x squared plus y squared plus z squared. And force between Earth and Moon is just partial derivative. So partial x, partial v, partial y, partial v, partial g, partial v is, we have x plus y squared 2 g m x, we have minus sign, right? Partial y, y, z, so minus sign means gravitational force is attractive. So Earth and Moon attract each other. And they are balanced by the centripetal force, the rotation of the Moon. So Newton did 1650. So he used the calculus to calculate the movement of the planet and moon and other celestial bodies. (1765) is also an important year. That is James Watt. So, anybody remembers what James Watt did in 1765? He invented the steam engine. He used the calculus to design the movement of the mechanical part. It took about 100 years from the invention of the calculus to the invention of the steam engine. And steam engine is a symbol for the Industrial Revolution, right? It leads to the then 1850, James Clerk Maxwell formulates the electromagnetic theory. And 1880, Michael Faraday Anybody knows what Michael Faraday did, 1880? He invented electricity. Generator. So Michael Faraday actually contributed to the very pivotal role for the modern civilization. Without electricity, we don't have these things like that, right? We don't have a projector. 1894, Hertz. He invented microwave communication. So we have iPhone because of Hertz. And 1925, birth of quantum mechanics. So if we take a look at the chronicles, it took about 400 years from the invention of calculus to the discovery of quantum mechanics. 400 years. But those history are not the subject for quiz, just for your education, common sense. So this is our 0. 2 century 1550 Newton. This is a very important event at 08. There were some claims that Pythagoras might have actually discovered the calculus. But around 080, the Alexandria library was burned down and destroyed. And then this is the Dark Age. So, if there is alternative history, if the Alexandrian library was not burned down, we might have calculus 2,000 years ago. Then we might have industrial revolution started around 2nd century AD. Maybe we are now living in Mars, or maybe beyond that. So it's kind of sad thing that all the knowledge was lost and rediscovered after 2,000 years. So maybe you can take a break for 5 minutes and continue. Yeah. So how do we find solutions? Say, okay, we have some very simple differential equation. Yes. Okay, say dy dx is 1 over 1 plus x squared. But in this case, we know that this is a derivative. We know that this is dxt tangent inverse x, right? So y is actually tangent inverse x. But anything we can add 0, constant, because dxtc is 0, right? One minus x squared. We happen to know that this is also derivative of cosine inverse x, right? We can add always 0. C. So y can be cosine inverse x plus c. So actually differential equation is not too difficult if you happen to know lots of derivatives. But this is the most simplest case. But what if this form, right? The simple dy dx is something. So we are going to try in more complicated form. This is called source term. When Qx is 0, we say the equation is homogeneous. When Qx is non-zero, inhomogeneous. So previously we found that if we can solve dx dy is some qx, right? We can solve this form. If qx is some dx t something, right? If we know the function, the derivative for which gives qx, right? So basically we can solve this kind of problem. Dx dy is qx. If qx is some, we know the original function, the derivative of which gives qx. But this form and this form is quite different, right? So we need to find a way to solve this equation. We have qx if we can transform the above equation into dx dz qx. So if we can transform into the following, then you might be able to solve, right? The typical first order differential equation is of this form, but because of this term, it is not very straightforward to solve this equation. But somehow, if we can transform this into this form, and happen to know the function which gives the derivative of the function gives this term, then we can solve this equation, right? So we try g x by some multiplying hx, yx. And qx, same function, original function. Okay, so this is very important step. So you must, do you agree that if you can transform this into this form, then we can close it, right? This is difficult to solve, but somehow you can transform this equation into this form, then we might be able to solve this equation, right? So this is similar to the so let's try zx is hx times yx and see what happens. Then dx dc is dx dh y plus h dx dy is hq. So if we divide by h, we have dx dy 1 over h dx dh y is q. Oh, this term must be the same, right? So this has to be px. And we are familiar with this form. This is what? Logarithmic derivative, right? This is a logarithmic derivative. So this is also dx d ln x log hx. So if we happen to know the logarithmic derivative of hx is px, then we can basically solve this equation, right? This hx is called integral factor, integrating factor. This is name, integrating factor. So basically, we just need to solve this equation. So once we found this, we can just solve this. txt, hxy, hxqx. So here comes the importance of the integrating factor and logarithmic derivative. So this may be conceptually very difficult to understand. So let's do some examples. Dx dy 1 over cosine y x y is equal to 0. The goal is we just find out dx hx y is equal to 0, right? So dx dhy plus h dx dy equal to 0, or dx dy plus 1 over h dx dh y is equal to 0. And this must be same as this, or dxt log hx is 1 over cosine x secant x. Actually, we covered this. We know the tangent x plus secant x, right? So we know hx, which is tangent x plus secant x, right? We found that some time ago dxt log tangent x plus secant x is secant x, right? About 2 weeks ago, last week or 2 weeks ago? Some time ago, right? So this equation is the same as this. dxt tangent x plus the secant x y equals 0, or dxtc. So y is actually tangent x plus the secant x over c. You need time to copy? Bit more complicated case. Oh. How about this? Tangent x. Oh, this is really difficult. So we know that hx is given by tangent x plus the secant x, right? So we transform this equation into this. dxt tangent x plus secant x y hx tangent x tangent x tangent square x plus tangent x secant x. What is the derivative of tangent x? We have done this. 1 plus tangent square x, right? What is dx d secant x? Tangent x secant x, right? We can check. Dx d cosine x minus cosine square minus sine x, right? So it's cosine x, sine x, cosine x. So this is tangent x, secant x, right? So with this knowledge, what you can do is we add plus 1, minus 1. Right? So we just added 1. So we add here 1. And subtract 1. Right? Then this becomes dx d tangent x dx d secant x minus dx dx, and you can add a 0, dx d some constant. So this is dx d tangent x plus secant x minus x plus c. Where should I put this? I like to too complicated. I can move this here. So dx d tangent x plus secant x y is dx d tangent x plus secant x minus x plus c. So therefore y is, you just divide by everything by tangent per secant x. So tangent x secant x tangent x secant x minus x plus c, 1 minus tangent x plus secant x c minus x. Too complicated? So if you know many logarithmic derivatives, at least you can solve first-order differential case very easily. Another logarithmic derivative, let me see. So this is one good example. So integrating factor is very useful tool to solve for the solution of the first order differential equation. But the key idea is you have to know the logarithmic derivative. So let me see what else. Another example. Let's see what happens. If you take derivative, what do you get? The first term, just 1, right? 1 plus 2 square root x square plus 1, 2x, 1 plus x square root x square plus 1, right? Which is x plus square root x square plus 1 over x square plus 1. This is an interesting case. So if we divide by x plus square root of 1 everywhere, we get 1 over x plus square root of x square plus 1 dx d x plus square root of x square plus 1 is simply root x square plus 1, right? Well, this is another logarithmic derivative, which is dx d log x plus root x square plus 1. So if I have a problem such as dx dy plus equal to 0, then how can you solve this? Now we know that this you can transform this into hx y is equal to 0, right? And hx simply x plus square root of x squared plus 1, right? So this is dx some constant. The solution of this is simply x plus square root x squared plus 1, y is some constant, or y is c over x plus square root x squared plus 1. Right? What if they say x plus this is actually a very easy problem. Oh, no. Just simply say this. So maybe I should give it as x plus square root of x squared plus 1. This form. hx times x plus 8. Right? So they cancel each other. This is a U question. So they cancel each other. So x plus square root x squared plus 1, y is 1 over x squared plus c, or y is equal to x plus square root x squared plus 1, 1/2 x squared plus c, right? What else? So let's summarize somehow. So first order differential equation of the form px y equal to qx can be solved by transforming into the following. Qx and dxt log hx is px. Hx is integration factor. So I'll give you homework again. 5 and design the first order differential equation of the form on your own. So this homework is very important, and so at home, you can ask ChatGPT to give you some logarithmic derivatives. And using that, you can design your own first order differential equations and solve it. That could be a good exercise. So this is pretty much about the first order differential equations. And let's move on to the next topic, just briefly for some time. Any questions about first order differential equations or logarithmic derivative or integrating factor? So that means you understand all the topic? Or you are not sure until the next quiz? Okay, let's cover some more materials because we are not going to have class next week. Higher order ordinary differential equations. So a n x So when Qx is 0, it's homogeneous. Qx is non-zero, equal inhomogeneous. When a and x constant, we call this is ordinary differential with constant coefficient. So we are going to start with the constant coefficient, the most simplest case. Nth order. We need time to copy. Okay, so a n a 0, 1. Let's consider the homogeneous case first. So trial solution. So we say exponential lambda x. So constant coefficient can be solved by trial solutions first. So lambda exponential lambda x, lambda square exponential lambda x, etc. So if we use this trial solution, then we can transform the following: an lambda n exponential lambda x, an minus lambda n minus 1 lambda x, a1 lambda, a0 lambda x 0, right? Or an lambda n, an minus 1 lambda n minus 1, a1 lambda, a0 equal to 0. So this becomes algebraic equation. For example, so we need to find lambda 1, lambda n. So for example, three here, py 2y is equal to 0. So with trial solution, y equal exponential lambda x, lambda square, 3 lambda plus 2, y equal to 0, lambda plus 1, lambda plus 2, y equal to 0, lambda equal to minus 1, minus 2. So solution, we just add them together. Y equals c1 exponential minus x minus x c2 exponential minus 2x. And we need to determine those coefficients of c1 and c2 to determine. So how do we determine those coefficients? There are two conditions. One is initial condition or boundary conditions. Looks like you seems to be a bit tired, covering too much material. So I just mention about the boundary conditions and initial conditions, and then maybe you can stop. So find C1 and C2, two kind of conditions. y0 and dx dy0. This is initial condition. Or ya, yb. The value of y. This is called boundary condition. So for the details, maybe we can stop here today and continue next week. The most important lesson today is the first order differential equation can be solved by using logarithmic derivative. So try to find out 5 logarithmic derivative and design your own first order differential equation.
전기회로 수업시간에 댐핑이 나오는 이 엘지브릭 이퀘이션이 거기서 말하는 캐릭터리스틱 이퀘이션
맞아요.
똑같은 건가? 아, 네.
그 캐릭터리스틱 이퀘이션이라고도 해요.
아, 네.
전기회로에서 이렇게 회로하면 이렇게 나오죠.
아, 예, 이렇게 핑크색이 나오는데, 아, 이게 그건가?
알지브릭 이퀘이션이 그 캐릭터리스틱이 같은 거예요.
아, 예.